So I'm Guillaume Laforge. I'm working for VMware. I've been working on the Groovy project for the past 8 or 9 years now. Well, I initiated the creation of some frameworks from the Groovy ecosystem, like the Grails framework, the Gaelic toolkit for Google App Engine, etc. And I co-authored a couple of chapters of the Groovy in Action book. And well, if you want to follow me, here are a few links you might be interested in. So this presentation is going to be split in 2 parts. I'll cover, so the current major version is Groovy 2.0, but there are some interesting features which you might not be aware of, which were part of Groovy 1.8, which was released, when was that? I don't even remember the date, but close to 1 year ago. Well, these are the features I'll cover, and in a second part, I'll cover the specific features of Groovy 2.0. Okay, so one of my favorite features, well, Groovy is used in different contexts as an embedded language for domain-specific language, for business domains. It can be used as a scripting language when you're in your shell. It can be used in various contexts. And domain-specific languages is, I would say, a sweet spot for Groovy. And one of the features which came in Groovy 1.8 was what we call command chain. It's the ability to have readable sentences, almost plain English sentences, but which are actually valid Groovy code. And that's for chained method calls, as I will show you in a few seconds. For example, something like this, pull request on GitHub. It looks like a plain English sentence or an expression. And before Groovy 1.8, it wouldn't have been something that the Groovy compiler could compile. But since Groovy 1.8 and then 2.0, we can compile that, and it's actually an alternation of method names. Pool is a method name, on is a method name, and parameters. So you've got this alternation, method names and parameters. And this is actually equivalent to this code, right? That's chained method calls. That's why we call that feature command chains. So this is the simple example where I just have one parameter, but you can have several parameters. You can use named parameters, etc. And let me show you some further examples. Here, with multiple arguments, take coffee with sugar, milk, and liqueur. That's, again, a sentence, but that's valid Groovy code. You can use named arguments, and I'll put back the parents and dots afterwards. I'll show you. You can also use closures for creating your own control structures. So if you're into behavior-driven development, testing frameworks provide that kind of constructs, given, when, then. You can, there's one case where you actually need parentheses. It's when you have a method in the chain which doesn't take any argument. So this is one of the cases where parents are required. And another example, so far you were seeing method parameters, but you can also have method parameters, and the odd part being a property access. So let me put the parents and dots back. So here you see that the with method in the middle is the one taking actually 2 arguments, sugar and milk. The second one is interesting in the sense that visually we have this impression that the colon separates both parts of the sentence, but this whole part there is actually a named argument. And this one, it's quite simple. It's like just putting back the parents around the closures. And yeah, the other ones are quite straightforward. So it opens the doors for some interesting DSLs for business languages. And I also know some persons in the room who are already using that in their projects. And by the way, I forgot to ask an important question. Who's using Groovy or is familiar with it? Okay, so a majority. So because it's, a talk about what's new and not so much an introduction talk. So I'll spare you the details, but just in a nutshell, for those who are not familiar, Groovy is a language which is, well, it's a dynamic language which derives from the Java language. We, at the syntax level, most of Java constructs is also valid Groovy constructs, and it has the same behavior. Plus, we add some stuff. We simplify some things, like we have real properties, we have closures, etc. Plus some APIs. So, in a nutshell, that's the definition, a quick definition of Groovy. So let's come back to the features, the new features. From the Groovy ecosystem, there's a project called GPars, which is now bundled with the Groovy distribution when you download the Groovy distribution. GPars is a very interesting library which covers all things related to parallelism, concurrency, etc. And it provides different, let's say, it provides some syntax sugar on top of different constructs like actors, the fork join stuff of Java util concurrent, data flow variables, which is an interesting concept, agents, etc. So all these concurrent paradigms are supported by the GPars library. So whenever you want to run things in parallel, etc., you should have a look at this very interesting library. What's also interesting is that, well, perhaps some of you would like to use Groovy in production, but for some reason you're not allowed to or something like that. But for example, if you want to use GPars from Java, you can do it as well. So it's friendlier for Groovy developers because of the syntax sugar. But you can also use that library from Java itself. GPars.codehouse.org if you want to learn more about that library. Closures, which is a key cornerstone of the language, has seen several improvements, so I'll just focus on the ones which are in bold. Let's start with this one. Closure annotation parameters. So that's a bit of a mouthful. When you use annotations in Java, annotations can take parameters. They can take strings, primitive types, class values, other annotations, arrays of all these things. Am I forgetting something? Yeah, probably got them all. But it cannot really extend annotation to support some other types. And actually, we have a little trick there. We are able to use closures as parameters of your annotations, which allows us to support that nice notation. The trick is that actually we are encoding the closure, which is here, in the form of a class. So because the JVM doesn't allow us to provide other types of parameters, so we encode the closure in the form of a class. And in this example, I'm actually doing design by contract, like is available on languages like the IFL language. So I define my annotation, and I put an invariant annotation on my distance class, and then I create a distance using Groovy's named constructors, with named parameters, which is going to call the setters on those two properties. And then I retrieve the closure, which is associated with this class, and then I can call that closure with my distance instance, and then I'm able to check that this predicate is valid. There's actually a library called gcontracts that you can use, which provide the full-blown design by contract, like preconditions, postconditions, dealing with inheritance, and so on. So it opens again some interesting perspectives. For example, if you want to reuse closures for doing things like validation, you could say, okay, this field or a string should be longer than 10 characters and that kind of stuff. So this feature is interesting for framework developers. So that's quite nice. Then closures are used a lot in the context of functional programming. So Groovy is an object-oriented programming, a dynamic language, etc., but it also supports some other flavors, kind of programming. So functional flavor, there's definitely a functional flavor to Groovy, especially with the use of closures. So what you see here is a closure between the curly braces, taking some parameters, and then the actual body of the closure. So here I mimic a closure which does an addition, which adds A and B, but I'm inserting a sleep 1000 milliseconds statement before returning the value, so that the computation is slowed down, okay? So fortunately, when you do sums in Groovy, they don't take 1 second for each sum. It would be a bit of a pity. And then I actually called a new method on closures, which is memoize. This is the memoization pattern, so that it creates a new closure which remembers the outcome of previous invocations with the same set of closure parameter values. So the first time you're going to call that closure with 1 and 2, it's going to return 3. Okay, that's correct. But after 1 second. Okay, but on the second invocation, it's going to return immediately because it's going to retrieve the value from a cache. Then if I take some other values which are not in the cache, it's going to take 1 second again, and the second invocation of that closure will return immediately. You can actually, you have a bit more control on this feature. For example, you can say you want to memoize at least 10 invocations, at most 10 invocations, or you can even say between 10 and 20 invocations. If you're, yeah, there's a question already.
What does that mean for object? Does it use equal, or must it be strings? Or?
So how, what in terms of implementation details, what is it using?
What is equal parameters?
So I think it's using, I'd have to check the implementation because I don't remember. So it's either using, no, I think it's equals. I think it's equals which is being used there, not identity equality. Yeah, yeah. I'd have to double check. I can check double check that after by looking at the code, if you will, if you're interested. What else? Yeah, and so there's actually a list recently used cache, and for example, even if you just use memoize without putting some specific bounds, if you have some, if you're running low on memory, there will be, the next time the garbage collector will come, it will claim what's in the cache, so you don't have to be worried about running out of memory, even if you don't specify some upper bounds. So don't hesitate to interrupt me with questions. I'm happy to take them throughout the presentation. Okay? Groovy is well known for its support of XML. Back in the day where when XML was popular, the dynamic nature of the language made Groovy very powerful when dealing with XML, both for consuming and for producing XML, because we can navigate an XML node graph very easily, because we don't have to do some Java marshalling and marshalling to get the intermediary nodes. We can just go through with, well, let me show you what it looks like with the JSON support. And well, we had that support for XML since the beginning of Groovy, but these days most of the REST APIs that you can find, whether it's I've got an example with the GitHub REST API, which is using JSON. So it was quite natural to add the same kind of support for JSON as we had for XML. So let me show you. So I tried to run that example just before doing my presentation, but so it's an old example I had, and the GitHub guys changed their API a little bit. So I shortened the URL here, but it's not the correct URL, and the path to the commit messages has changed. So I'd have to update this example a little bit, but you will get the idea anyway. So in Groovy, even before mentioning the JSON slurper class, when you do new URL, it's going to create a java.net URL. But Groovy also adds utility methods, extension methods to types from the JDK. So on the URL class, perhaps it's even a final class, I don't remember, but we can add new methods, decorate existing classes from the JDK or third-party classes with additional methods. And .text is a shortcut for calling getText, the getText method, which has been added to URL by the Groovy development kit, as we call it, the GDK. And with just new URL, .text, you're doing an HTTP GET for this remote resource. So in just one line of code, you can consume REST services very easily. So you don't have to create, to open URL connection, get the stream, create an input stream reader, put all the lines that you read inside a string builder or something like that. In just one line of code, you save 10 lines of Java code. So I retrieved the remote payload. Then I instantiated the JSON slurper class, which has so the API looks like the XML support. It's got a parse text method, which I can call on this text JSON payload, and then, although I didn't define some intermediary data structures, I can directly go through the JSON graph and say, okay, I want to retrieve all the commit nodes in that graph. I want to retrieve the message node of each commit message so that I can print each message. Okay, so in just a few lines of code, I'm able to quickly do something with some remote payloads. So that's quite powerful. So that's for consuming JSON content, but you can also produce JSON content. So similarly to our XML support, we've got a builder class on which you can call. So person is not a method that actually exists on the JSON builder class, but it's somehow interpreted by Groovy to create a person key in the JSON payload that we are creating. Inside that, I'm going to have, well, let me show you what it generates. So it's creating an object with a person key, which is, well, I associate another JSON object there, again with key and values, name Guillaume, age 35, and the pets. When I have a list here of pets, it's going to create a JSON array, and that's why you see the square brackets. And well, that's basically it. So it looks like, again, our XML support, but well, that's for JSON. And sometimes usually the APIs return some compressed somehow JSON because it's not nicely formatted for human reading. So when you have a payload like that, and you want to, you know, for debug purpose or something like that, for debugging purpose, you can just call prettyprint from that JSON output class and have a nice output from that. So this is those two are obviously equivalent. So that's it for the JSON support. Any questions so far? No? Good. Oh yes, there's one.
Just one question about the performances. Do you have improved something?
Sorry, say it a bit louder.
Sorry. About the performances of the new JSON support, is it better?
So I think that, for example, the fastest JSON library, I think these days is Jackson, and Jackson is faster than this implementation. This one is has got the same performance or slightly better than the JSON-lib library, which Groovy developer used to use before this support. But usually it's good enough. But perhaps if you really care about performance, the Jackson one might be a bit better. Okay.
The question would be compared to the previous version of Groovy?
No, that's it hasn't changed much since Groovy 1.8. But there are some, for example, the builder, which was compiled. Well, I'll come back to some of the features of Groovy 2.0, which are about static type checking and static compilation. And there are some things that we're going to compile statically to gain better performance in upcoming releases. So we might revisit that. But currently, it's more or less the same performance between the latest major versions of Groovy. Okay? A key facility of Groovy is what we call AST transformations. So AST stands for abstract syntax tree. That's the in-memory representation of a Groovy program. And we have this, this is a bit like a compiler plugin. You can plug into the Groovy compiler to change the structure of your program before it is actually compiled down to bytecode. And thanks to that capability, we can annotate some elements of your programs. For example, you can annotate a class, a method, a field, etc. And actually do some transformation before generating bytecode. And we have several transformations which were new in Groovy 1.8. And the first ones came in 1.6, then some other ones in 1.7, and the latest ones in Groovy 1.8 and 2.0 as well, which simplify, I would say, the life of developers. One of the key goals of Groovy, the design goal, I could say, is that we always try to simplify the life of developers by, for example, allowing you to write less boilerplate code. Okay, so let me show you a few examples. So I'm not going to show you all of them because it's a bit too long, and I want to spend some precious time on Groovy 2.0. We have this @log annotation, which triggers a transformation, which injects a logger into your classes, and which does. I think I'm going to ask you a question. When you do some logging in your classes, so first of all, a log is instantiated and as a field of that class. So you don't have to declare it, and you can use the log variable directly, log.info. And is there something missing in that example? Something that you usually do when using logging APIs? Any idea? Yep, enable. So usually when you write something like log.info, you surround that statement with if, so depending on the API you use, but if log is debug enabled, etc. So depending on the API, that's not exactly the same call. But to avoid the computation of complex strings and that kind of stuff, so you surround that code with if debug info enabled, etc. And actually the transformation is looking into your code to wrap calls to the logging API. So it's transparent, it's done for you. So even if you forget, the Groovy compiler will do the job for you. Okay? So that's a key aspect of Groovy to try to help you focus on the job rather than the technical, boring details. So there are different implementations for the different loggers, like commands logging, log4j, etc. When you are executing Groovy business rules, for example, you might want to check that the code which is being run on your system is somehow safe. For example, you don't want users' code perhaps to do infinite loops or to run longer than a certain period of time. And there are some transformations which take care of that. For example, if you had a script which did while true, consuming lots of CPU, you could use the thread interrupt transformation, which actually somehow transparently inject statements like that. Thread, current thread is interrupted. So if someone interrupted the thread externally in another thread, you'd be able to stop the execution of that loop. So for people who execute Groovy scripts coming from elsewhere, from third parties, this can be handy. And also there's a feature I'm not going to mention, but you can hide the usage of those annotations so that the guys writing the scripts don't even have to take care of adding the import. So you can hide that. So this one is triggered when the thread is interrupted, but there's also one for custom conditions. If you, let's say you run low on memory or something like that, you can define your own conditions. And there's another one for timed interrupt where you can specify, okay, I want you to stop the execution after 10 seconds and that kind of stuff. Some other handy transformations, for example, if you want to generate some friendly toString method, instead of person at 61AF blah blah blah. You can also write your own toString method, obviously, but if you want a quick toString, you can just annotate your class with @toString, and it's going to generate that kind of. Do you see, by the way, from the back I know when you're in the back of the room, it's not always readable. You see the last statements correctly? Yeah? No? You're sleeping? Okay. Well, or I could, yeah, well. So toString, we have also equals and hashcode, which generates, well, equals and hashcode methods. Nothing really fancy. So for those who know the Lombok project for Java, it's a bit the same kind of transforms somehow to inject equals and hashcode methods. So I created two coordinates, and I can check they are actually equals and that their hashcode are the same. So again, that's the compiler and the transformation which does the job for you to implement those methods. Tuple constructor, that's creating the usual constructor with the different parameters. So I can use a name and age, and it's creating the person, string name, int age constructor. And yeah, that's it. That's all I wanted to say about it. Another one about, again, boilerplate code. When you create your own custom exceptions, you have to extend exceptions. And you have to, even if your constructors don't do anything, more clever than just forwarding to a super, usually you always have that boilerplate because you have to specify the four constructors and call super. But if you just annotate that class with @inherit constructors, it's going to inherit from the parent class constructors and just delegate to super. And that's it for some of the transformations, and there are many other features, but I wouldn't have time to speak about the Groovy 2.0 features, so let's move on. and speak about Groovy 2.0. Some questions before moving forward to the 2.0 features? No? It's okay? Good. So what's in store for Groovy 2.0? So first of all, we released Groovy 2.0 at the end of June. And since then we released, there's a question at the back? So at log, does it do what? I didn't hear you. Yeah. Yeah, it's the isLog enabled is added automatically by that transformation. So it's done for you. You don't have to do it. Yeah. So we released Groovy 2.0 in June, and since then we released some other dot releases. So the current major version is 2.0.4 with bug fixes and so on. And so what's in store? The key themes are modularity, Java 7 alignments with Project Coin, and also the InvokeDynamic support. And there's a static theme with static type checking and static compilation. Let's have a look at that. So people using Groovy in their project are usually using what we call the Groovy all jar. So it's a Groovy jar containing all the language plus all the APIs, because Groovy is not just about the language, but it's also about APIs which are provided, like there's a template engine, you can create swing UIs, you can do lots of things with Groovy in a nice and groovy way. This jar also embeds ASM for bytecode generation and Antler for parsing, which are the two jars which are essential for Groovy to be able to parse programs and compile to bytecode. And this big jar weighs in at 6 megabytes, which is quite big. Well, these days with our big hard drives and so on, it doesn't matter that much, but well, still it was big. So the thing we had in mind was that not everybody needs everything. For example, in your project, perhaps you don't need a template engine. You don't need the end scripting capabilities to reuse end tasks. So what about splitting this big Groovy jar into smaller jars? So a Groovy core jar with just the language, basically, and the ability to parse and compile the language, and some smaller jars for different modules, okay? And I'll say a few words about the last bullet. Let me not go too far. So now the core jar is just 3 megabytes, so it's half the size, and we have those modules. The console for the Groovy Swing console, we have the servlet support, template support, etc. Or the JSON support is also a library in itself that you can use. So you are able to pick up just the features that you want. But you can also still use the big Groovy all jar if you don't want to choose. And that was the last bullet of the other slide that I wanted to mention. In the way we created and we made Groovy modular, we introduced a feature which we call extension modules or extension methods, which is the capability of decorating types with additional methods. So for example, here I want to add a new method to string. Method to string, not to string. So that I can use Guillaume introduces Cedric. So it's a method which doesn't exist in Java long string, but a method that I'm going to add. So there are different mechanisms for dynamically adding methods to types, thanks to Expando meta class, thanks to Groovy categories, etc. But this is another mechanism, which is also interesting because it also works with static type checking and static compilation, and is also friendly towards IDEs for code completion. So it has some additional benefits compared to all the other mechanisms that existed for adding new methods to types. So I create a class called string extension with some static methods. The first parameter is the actual type on which I add a new method, and the remaining parameters are the actual parameters that are passed to the method when I actually call it in my code. So self here is going to contain the Guillaume string, and Cédric is going to be put in the second parameter here. And then I'm returning a G-string, an interpolated string, and I can replace the name and self variables, and then I'm able to use that Guillaume introduces Cédric. And to do that, so it's exactly like Groovy categories for those who know them. It's a little detail. We can do that for instance method, but also for static methods. That's the same mechanism, except that here we don't care about the actual variable, but we just care about the type of the first parameter. So this is the same kind of structure for the extension modules. And you have to create a descriptor for your module with a name, a version, the various classes which provide instance methods, and a list of classes which provide static methods. And you put that into this file in meta-inf services, etc. So this is a nice way for extending JDK classes or third-party classes from third-party libraries. Okay. And yeah, I'll speak again about static compilation at the end of the presentation. So it's nice because this mechanism works well with static type checking and compilation. But I'll come back to that. I mentioned Java 7 and JDK 7 theme. So since Groovy supports, let's say, 99% of Java syntax, we also thought that it was a good idea to provide the same new enhancements that were added in Java 7. For example, the binary literals for defining numbers, so with 1, 0, 1, 1, 1, etc. So we support that notation. We also support the underscores in your literals. So that's nice for things like credit card numbers or separating 8 bits, etc. We also have the multicatch, where you can catch different exceptions, IO exception as well as null pointer exception, instead of creating 2 different catch blocks. And Groovy 2 supports InvokeDynamic. InvokeDynamic is the new feature from Java 7 and JDK 7 to improve the life of dynamic language implementers. So the idea is to provide some specific bytecode instructions as well as APIs to improve invocation of dynamic methods. And the goal of InvokeDynamic, one of the key goals, is to bring some more performance for dynamic method calls. And in the long run, it will also give us the opportunity to get rid of some of the techniques we used to improve the performance of Groovy. Okay, and now the big two big features, which are static type checking and static compilation. So one of the complaints we hear from static language guys or from newcomers to Groovy is that there's this fear, which is more a cliche than a real problem in practice, this fear that, okay, it's a dynamic language, so when I make a typo in a variable name or in a method name, I'll get the error at runtime when my application is deployed in production. Usually in practice, you create tests, you run your code in a way or another, so you never get that in production. But anyway, if you want to get early feedback for common mistakes like typos in methods and variable names, if you return some wrong values according to the return type of the method, etc. If you want that kind of early feedback from the compiler, you can now use static type checking. Let me show you. For example, in this little class, I have a method called method. That's very funky method name. And actually, I made an obvious typo here, and I also have a local variable name, and I made another typo. Now, if you compile that, because you used the TypeChecked annotation, the compiler will throw compilation errors because it didn't recognize that method and that variable, which don't exist. And the annotation can be put at the method level or at the class level. So you can have the same kind of feedback from the Groovy C compiler as you would get from the Java C compiler. It can check wrong arguments. Let's say you want to assign an object into a primitive value, or let's say you've got an array of strings and you want to put the first element of that array into an int, etc. All these things will also trigger compilation errors, like in Java, obviously. Another example, if you have a method which returns an int, so here in the else part it's okay, 42 is an integer, but here I'm trying to return a string, so it's going to complain again with a compilation error and not a runtime error. And some things like, for example, with string builders, you can use that notation to append strings to your string builder. And automatically Groovy uses toString, although this is a string builder here, the value of that expression is the string builder. Groovy automatically calls toString when you return a string. So for that kind of things, the Groovy compiler won't complain. So you can still write Groovy code the same old way you've been writing Groovy code, including things like the automatic type coercions that Groovy provides. So just annotate some parts of your programs with TypeChecked, especially the parts not needing dynamic features, so that you can get the same kind of feedback from the compiler. With static type checking, we also do type inference. So here name, although we didn't say string name, but this variable holds a string, so I can call things like toUpperCase. I can call trim, which is a method that was added by the Groovy development kit. And yeah, that's pretty much it. You can do, it figures that the variable n from the for loop is actually an int. Obviously, we created an int array, so it works, it just works. I mentioned that you should be using TypeChecked on Groovy code which are actually not dynamic, because the compiler cannot really know what you're doing when you're using some specific dynamic features. For example, when you use builders for creating HTML markup, you can create HTML body div nodes which are dynamic method calls. And this kind of stuff cannot be type checked because you could be creating any kind of node. So there's no way the compiler can figure out what's your intent. So you can mix methods which are statically checked and usual dynamic methods by just annotating the ones which are type checked. Something in Java which has always been painful, is the fact that when you've got some value here, which is just an object, and you want to do different computations depending on the actual type of that parameter. When you do if var instance of string, then if you want to use the toUpperCase methods, you have to create a local variable, or you have to use cast, etc. It's a bit of boilerplate code, but the Groovy compiler is smart enough to know that, okay, if you made that check, that means that at that point we know val is a string, so you can call to uppercase, obviously. And what's the other part? Yeah, so you don't need casts, and it also understands, well, the Groovy development kit methods added to things like strings. We're going into some more hairy details. When you have something like, so here my method returns a list which contains an integer and 3.14 in Groovy by default it's a big decimal. So what's the common type? What would be the inferred type of something of that expression? What is the inferred type of the return value of that method? List of, so I hear objects, numbers. Okay. What's interesting is that it's able to figure out that numbers, so it's indeed a list of number, but numbers, well, number doesn't implement comparable, but integer and big decimal do. So it's able to figure out that the actual type is a list of number and comparable objects, right? And it's not something, it's a, you cannot really express that in Java. There's no way to provide a notation for that. So it's a quite fine-grained type that we infer here. So with Molio, things are smoother. And we also figure out, so that, well, it's called lowest upper bound, and we usually write LUB, so that's why I made that bad joke. Anyway, I had to explain because we always say the lube of blah 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 is, it's a, but well, it's more a joke for the Groovy developers implementing the language. And when I speak about type inference, we have this, so it's part of type inference, an aspect we call flow typing. Sometimes people, so it's not really a good practice to do that, but still, users of Groovy sometimes do that. You use a variable which is not typed. So in var, I put an integer. Then, well, I could put that into that in variable. Then in var, I could put a string. So I'm changing the type of the variable. But, well, if you're changing the value and the type of that variable, let's say here I can call to integer because Groovy figures out that this is actually a string. But then I'm putting back again an integer, a number. And if I call to uppercase, it's going to throw a compilation error because, okay, you changed again the type of var, but now it's a number, so there's no to uppercase method, right? So it's following the flow of assignments to figure out, okay, at this point it's containing a string, a number, etc. So some gotchas. Type checking is interesting, but it's limited in the sense that it won't work for most of the dynamic aspects, like the builders, like expand meta class. And I think I had some further example of that. For example, when you use, like it's often used in the Grails web framework to extend classes. For example, if you want to add a foo method on integer, you have to access the meta class property, which is a dynamic property. And then foo is also, well, a dynamic method, which doesn't really exist on integer. So this is actually not allowed by the static type checker because we can never know someone from another thread could add a new method. Perhaps, or it could remove the foo method, etc. So I cannot make any guarantee that the foo method is actually here. So that's why we've taken a safe approach to that problem by disallowing certain dynamic aspects of the language when you use type checking, at least. And sometimes you have to be explicit. For example, when you want to transform that list into a list of uppercase values, the type checker will complain because it, the default variable of that closure, I mean, the list might be coming from elsewhere, and you're not sure if it's just containing strings. It could contain numbers and whatever. So you have to be a bit more explicit by specifying, okay, the parameter is actually a string, so that the type checker is happier. But we are working on some solutions to be able to avoid having to type things, so that when you can figure out, okay, the type checker can know, in this specific case, at least, that it's a list of string, so it shouldn't require that string it stuff. Okay, I think I can skip some of those details here. What time is it? Still have 5 or 7 minutes. There are some cases where things are harder to figure out. For example, if there's a variable, and it's related to flow typing that I mentioned earlier, sometimes, okay, a variable can contain a string, that it could contain a date, but that closure could be executed or not. We have no guarantee. For example, if we pass that closure to some other class, or imagine that you do if random and you execute the closure or not, depending on the random value. There's no way the compiler can know what if the closure is actually called or not at runtime. And, well, at compile time, it cannot know. So we complain, the compiler complains and say, okay, this is not okay. Because, okay, we assign a different value here. Here it's obvious that we do change the variable, but you can't always know this is the case. So in the end, what you can call here is the lowest upper bound, and perhaps it's better illustrated with this other example. Here I have A and B, which extends A. So I create a new variable with A, an instance of A, and here in the closure it's an instance of B. So whether the closure is executed or not, we know that at least that variable is going to contain an A or a B. But the foo method is available on both A and B. So the compiler is clever enough to figure that out and not complain here. Okay. Now that we did static type checking, the compiler knows a lot about the type information which is available. Okay. So why not also generate the same kind of bytecode that the JavaC compiler generates? And well, that's what we did. If you use static compilation, and this is triggered by @compile static annotation, so it provides type safety by reusing the static type checking. It obviously provides faster code, so more performance. And also, since the actual method calls, etc., are not going through the dynamic heart of Groovy, the multi-object protocol, it's also immune to monkey patching, because someone in a dynamic part of your application could have changed how plus works, all that kind of weird stuff. So we're able to be, well, to protect you from people trying to change the behavior of your code from some other thread or something like that. And in that case, just like when you use static type checking, you lose the dynamic features and dynamic method dispatch, but you gain some nice performance. Like the previous example with TypeChecked, you can statically compile certain methods, and for example, when you want to use a builder, a Groovy builder, which is dynamic feature, well, this part don't compile it statically. Okay, so you can mix and match statically compiled code and dynamically with dynamic dispatch code. So what about performance? I've done some small benchmarks, so I haven't updated the figures with 204. So this was with, I think, 200. So I took some usual micro benchmarks. So micro benchmarks are worth what they're worth. So beware of micro benchmarks because they never really do justice to the code you actually run. I mean, your business code, your real application. So you'd better do some actual measures of performance of your code rather than relying on what micro benchmarks say. In Groovy 1.7, we added some code for when you were doing some primitive type calculations. Not in 1.7, sorry. That was in 1.8 that we introduced that. So for code relying on number crunching, we got some good performance thanks to those improvements. And then in Groovy 2.0, with static compilation, since we generate pretty much the same bytecode as Java, well, if you just look at the numbers anyway, without any kind of optimizations, if you did a Fibonacci implementation, you could be, 10 times, more than 10 times 12, or yeah, something like 12 or 13 times slower than Java. So this is a worst case scenario, okay? Because usually your code is not 13 times slower than Java. So these micro benchmarks are interesting for us because they show the worst case performance for Groovy. But usually it's not that slow, fortunately. And if you look at, if you just compare those three benchmarks in terms of numbers, this is usually as fast or almost as fast as Java. Okay? So there are still some cases where we can do, perhaps in Groovy 2.1, etc., we'll be able to squeeze some further performance because perhaps we still have some redundant bytecode instructions and that kind of things. But generally speaking, the goal is to be just as fast as Java for those parts which are statically compiled. Okay? So we've come to the end, and I want to have at least 1 minute for questions. The big themes of Groovy 2.0, the modularity, allowing you to also create your own extension modules. The JDK 7 related themes with the syntax enhancements of project coin like Multicatch, etc. The support of InvokeDynamic if you're lucky to run on JDK 7 in production, which is not yet the case everywhere. You can benefit from performance improvement when you run on JDK 7. And we also added a static theme with static type checking and static compilation for Groovy. That's it. Thanks a lot for your attention, and I'm happy to answer some questions.
What did you mean with the backport of InvokeDynamic for Java less than 7?
So if you don't use JDK 7, is there a way to backport to, let's say, when you run to JDK 6? There's a library which is an InvokeDynamic backport for earlier JDKs, but we haven't used it yet. So we might be using it at some point. But the thing is that for further versions, we might require JDK 7. But that will be for Groovy 3, which will be released in, let's say, in a year from now. And if you look at the performance, the current performance of JDK 7 with InvokeDynamic isn't that far from our own techniques for optimizing the Groovy bytecode. So there's not yet, till the VM engineers do their work, but I know they work on that because of lambdas, etc., which is InvokeDynamic. So we could do the backport. Currently, we haven't worked on that, and the performance is already good without it, and it wouldn't make a big difference because the backport is just a backport, so it's not really benefiting from the performance improvements the JVM engineers put in JDK 7.
Is that Java only? Is it pure Java, this library? Is that InvokeDynamic?
Pure, I mean, as long, I think, it would work for Groovy, it would work for the languages that would use InvokeDynamic calls.
So it's not tied to a specific VM, just to know about
Yeah, I don't remember the requirements, but it might still require JDK 6 at least, I think. I'm not 100% sure, but that might be the case. Other questions over there in the middle?
So, given all the, what I perceive as advantages to the static checking, just in terms of code safety, why wouldn't you want to use that? Because it looks like it would find a lot more errors at compile time than deploying it in runtime.
So like using it all the time instead of just once in a while? Yeah. So, well, it depends a lot on the kind of Groovy code that you write. For example, when you use APIs like the JSON support, XML support, usually you like the fact that Groovy is dynamic because you don't have to generate intermediary data structures and that kind of stuff. So usually you would probably use type checking for library code, for code that is not dynamic at all. And then if you notice some performance issues, also use static compilation for those parts which seem to be a hotspot. So you have to mix and decide depending on how you use the language and the various features. And let's mix and match. That's the point. Yes. Yes.
A related question to what you just said. Is it possible to get a dynamic annotation so that you could default the class to static and then
Oh yeah.
method is dynamic?
Yeah.
Because like if your default is
Right.
static and then you just get the live dynamic one, that would be
Yeah. So the thing is, you can. There's an annotation parameter. You can say skip. For example, if you annotated the whole class to be statically compiled, you could say, okay, I just want to skip that method to say, okay, don't statically compile it. But currently, we don't have the mechanism to apply it by default. But it's a feature request, and we might be adding it perhaps in 2.1 or something like that.
So I could say static on the whole class.
By default?
Skip.
Yeah, at least for now you can do that, yes. Yeah. And later on we might also, perhaps through a flag, when you call the compiler, whether it's through Ant, Maven, Gradle, etc., you'll be able to define a flag that says, okay, for all the classes I want them to be compiled statically by default. And, well, we haven't implemented that yet, but at least you can already do compile static, then compile static, skip, etc. Yeah. Over there, in the back. Yeah, okay. Okay, sure. So, thank you. And come and see me for the next questions.